So now we're going to look at the chain rule with e to the x. So anytime the exponent is not just x, but some other function of x, we have to use the chain rule with e of the g of x. So g of x represents that inside function. And so again, how the chain rule works is we do the derivative of the outside. So we know the derivative of e is itself, and we keep the inside. So we keep the exponent the same, and then we multiply by the derivative of that inside, which is this g of x, which is the exponent. So this is it in notation. In words, one way to think about it is you can take the derivative of e to the g of x is itself multiplied by the derivative of the exponent. So for example, if we look at this question, d dx means find the derivative of whatever function's inside of it. And so the derivative of this is e is itself. We keep that exponent the same, and then we multiply by the derivative of the exponent. So the derivative of 4x is 4. And usually I put the constant in front because it's a little neater, but it doesn't matter. So that would be your answer. So we're going to look at a few more examples. So this one is from the packet. So this one says find f prime of x. F of x equals 3e to the negative 6x. Okay, I'm finding the derivative. Anytime I find the derivative, I use the notation where I put the apostrophe on that function. So the 3 is a constant in front. I'm going to leave that there. Okay, the derivative of e is itself, and we keep the exponent the same, and then we multiply by the derivative of what's in the exponent. So the derivative of negative 6x is negative 6. And then because I'm multiplying, I can multiply these two constants together. And 3 times negative 6 is negative 18. And then I have e to the negative 6x. And that would be my answer for the derivative. Okay, so for two more examples, and especially the second one's a little bit more complicated. But for this first one, I want to find the derivative of f of x equals e to the exponent x squared minus 2x. Okay, so I'm taking the derivative. I'm going to put the derivative notation. The derivative of e is the outside, so it's itself. We leave the exponent the same. And then I'm going to multiply by the derivative of the exponent. Now, anytime it's more than one term, I need to put parentheses because I'm going to multiply e by everything that's here. So the derivative of x squared is 2x. The derivative of minus 2x is minus 2. So this is the answer. Again, I often put the e last, but it really doesn't matter. So this would be the answer. You could distribute the e, but you don't have to. But this would be the derivative. So one more example on the derivative of e to the x. So I have x times e to the square root of x, and I have to use the product rule because I'm multiplying two functions of x. So when I do the product rule, I separate the two functions and I call one, you can use any letters, but normal notation is f and g. Just note that this f is not the same thing as the whole function. So f is that first part, which is x, and g is e to the square root of x. I'm going to make it e x to the 1/2 because anytime I take the derivative of square root, I need to change it to exponent notation, which is changing it to 1/2. So the derivative of x is 1, and then I'm going to take the derivative of this e to the x to the 1/2. So it's itself. The exponent stays the same, and then I'm going to multiply by the derivative of this exponent. So x to the 1/2. I bring the 1/2 down, I leave the x, and then I subtract 1 from the exponent. Okay, and you don't have to write out the -1, but I'm going to just to make sure. So I have e x to the 1/2 times 1/2, and then 1/2 minus 1 is negative 1/2. Now it depends on the problem whether you want to change this to a square root right away, but I wouldn't start that way because you might have to combine it with another x. And if so, it's easier if it's in exponent form compared to root form. So for my derivative of f prime, now I'm going to find the derivative of this entire function. So I put f prime of x for my notation. I'm going to do product rule. So product rule is my f, or my first, times the derivative of my g, or my second. So I'm going to put this part that's a little bit simplified, e x to the 1/2 times 1/2 x to the negative 1/2. Okay, then the product rule is plus, and then I do my second, so e x to the 1/2 times the derivative of the second. Okay, so product rule in general is like f times g prime plus g times f prime. And the order really doesn't matter. It just matters that you're taking the one and multiplying it by the derivative of the other. So now I'm going to simplify. Okay, so I'm going to bring the 1/2 out front. Because I'm multiplying and I have two things with the same base of x, I can add the exponents. So if I just write it out, this is a 1 if we don't write it. So it would be 1 plus negative 1/2. And then I have e x to the 1/2. So if I simplify that, 1 plus 1 negative 1/2 is a positive 1/2. So it becomes x to the positive 1/2. And then I have e to the x to the 1/2 times 1, which is just e to the x to the 1/2. So it's fine to leave it like that, or unless, like, I think the homework often says leave it in terms of square roots. So I would change all the 1/2 exponents to the square root. So this would become the square root of x, e to the square root of x plus e to the square root of x. And that would be my final simplified answer. So that's some examples on how to find the derivative of e to the x when we have to use the chain rule.